Hello everyone. Today we're examining a ruby glass-filled stone, one of the most challenging treatments to detect in gemology. We start with a general observation, holding the ruby between the tweezers. Glass filling, or clarity enhancement, involves introducing a glass-like substance into the fissures and inclusions of a ruby to improve its visual appeal. This process is often conducted to mask imperfections, allowing lower quality rubies to appear more valuable. Nothing looks suspicious yet. This gemstone passes the first visual test. But remember, ruby glass filled is a treatment not accepted by the market because it's not permanent. The glass filler can degrade over time, causing the stone to turn brown or semi-transparent. Now we are at 150 times magnification. And even now we can't see anything weird because there are many natural inclusions. Even if there is a black inclusion, that it should be checked properly because it looks like glassy, but we're not still sure. Now, at 10 times magnification, I turn the ruby to profile position. Here we notice something unusual: orange and blue patches. I flip the stone and observe orange lines that require closer inspection. The two diagnostic features of glass-filled ruby are gas bubbles and the flash effect. Now in close-up, I hold the stone steady to highlight these orange lines. They appear as distinct vertical streaks running across the lower part of the screen, right near the tweezers. These lines could be the filler itself, and a very faint flash effect is just starting to show. This is a major clue pointing to glass filling. And now we're about to change the illumination. We're going to switch to reflected light. Reflected light is the illumination technique where we shine the light from above directly onto the surface of the gem. This makes any fractures or surface features stand out clearly. At the beginning, there's a little trick. I need to adjust both the light and the position of the stone to get the reflection just right. On the table, using reflected illumination, I shine the light from above onto the ruby. The table reflects perfectly like a bright mirror. This technique makes every surface detail stand out. Fractures that were almost invisible before now become clearly visible. These are almost certainly the fractures the glass filling was meant to hide. Changing the angle of observation is essential in gemstone analysis. What you see from one angle can completely disappear from another. Optical effects like flash effect, birefringence, or pleochroism only appear at specific angles. That's why we constantly tilt and rotate the stone during analysis to catch features that only appear at specific angles. A single fixed view can easily miss the diagnostic signs that prove a treatment or confirm a natural origin. At 50 times magnification, we see something that looks like spattered glass pressed inside the ruby during the filling treatment. But this isn't a definitive clue yet. It still needs to be properly verified and checked. In profile position again, we observe natural inclusions. Ruby glass filled often contains both natural and artificial features. This treatment began around the year 2000. Turning the stone at 200 times magnification, we search for gas bubbles. What appear to be bubbles are actually crystals, but one true gas bubble emerges near an intensely orange fracture. This is another crucial clue. The picture is now nearly complete. We still need that final diagnostic confirmation to seal the full analysis and be absolutely certain about the nature of the gemstone. Now, with the gemstone in this position, we start to see many slightly noticeable flash effects with orange and blue colors. They begin slowly, becoming more noticeable as we tilt and rotate the stone. Tilting the ruby in profile position reveals the definitive proof, the flash effect. As we rotate the stone, orange and blue colors suddenly appear and then vanish, depending on the exact angle of observation. This is the classic flash effect of glass-filled ruby, an optical phenomenon created by the difference in refractive index between the ruby and the glass filler. The glass has a lower refractive index than the corundum. So, when light hits the boundary between the two materials, it produces this shifting orange and blue flash that appears and disappears as the angle changes. It's one of the most reliable diagnostic signs for this treatment. At the end of this gemological adventure, after carefully tilting, rotating, and checking every angle, we still haven't found the gas bubbles. Let's take one last look to see if we can spot them. And yes, we found them. These are the irrefutable signs of treatment. A ruby glass filled will eventually degrade, losing its beauty. If you enjoyed this gemological journey and want to learn more about gem identification, hit like and subscribe to the Gemological Institute of Genoa.